8F, solving equations. So what exactly is an equation? An equation is where you set two algebraic expressions equal to each other, such as x plus 2 is equal to 5 minus 7, or x minus 7. So that's an equation. You're just setting two things equal to each other. Even something as simple as x equal to 5 is an equation. So, get a different marker. What are some things that we need to know of that? Well, simplest equation we can get is something like A is equal to B. Right? That's an equation. We're setting A equal to B, saying that they are the same. Now, when dealing with equations, there are some rules that help us to work with them and to solve them. The first one is that if I take an equation and I add the same thing to both sides, A plus C is equal to B plus C. So I just took the equation A equals B and I added C to both sides. The addition property says that if I have an equation and I add the same thing to both sides, I have an equivalent equation. So that's the addition property. Now remember that addition and subtraction are essentially the same thing, right? If you add a negative number, it's the same as subtracting. So we could also say that A minus C is equal to B minus C if you subtract the same thing from both sides. I'm still going to leave that as the addition property because addition and subtraction are essentially the same operation. So if you add something to one side of the equation, you add the same thing to the other side of the equation, you haven't changed the relationship. If you subtract something from one side and you subtract it from the other, you haven't changed the relationship. So basically, you can have an equivalent equation by adding the same thing to both sides or subtracting the same thing from both sides. You can also do that by multiplying both sides by the same thing. So A times C is equal to B times C if A is equal to B. You multiply both sides, that's the multiplication property. The multiplication property. If you multiply both sides by the same amount, you have an equivalent equation. And remember we've said too that multiplication and division are essentially the same thing. If you want to turn division into multiplication, just multiply by the reciprocal, right? We learned that with fractions. So we can also say that if you divide both sides by the same thing, that's equivalent. So those can both fit into the multiplication property. Now, knowing this allows us to start manipulating equations and moving them around so that we can solve for a variable no matter where it is. In the past, we've dealt with solving for the variable already by itself. 7 plus 2 equals what? 7 plus 2 equals 9. When we say that, we're actually going 7 plus 2 equals x, right? Equals what? Well, x, okay. So 7 plus 2 equals x, so x is equal to 9, because 7 plus 2 is 9, so 9 is equal to x. We've been dealing with variables for the whole time that we've been doing mathematics. From the first day that you were taught mathematics and they started to teach you addition, you were dealing with algebra and variables because they would set up questions to say 1 plus 1 equals, and they would leave it blank, or they'd put a line there. Well, they're saying 1 plus 1 equals what? Or equals sum, or equals result, or equals x. You've always dealt with variables and with algebra. You just called it a word rather than calling it a variable. The sum of 1 plus 1 is 2. 1 plus 1 equals the sum. 1 plus 1 equals the result. 1 plus 1 equals answer. 1 plus 1 equals blank space. And we filled it in, we said 2. Well, 1 plus 1 equals x, x equals 2. So this isn't anything new for you. We tend to get a little scared because we see variables. And variables aren't numbers. So what do I do with something that's not a number? Well, I can treat it just like I always treated it. I can do the same things. I can add the variable, I can subtract the variable, I can multiply it, I can divide it. Everything in mathematics deals with addition, subtraction, multiplication, and division. It's just how we put it together. But now what we're going to do is, maybe that x isn't going to be on a side by itself already. Maybe we have something, and I'm going to call this a single step equation. So a single step equation, maybe I have x plus 4 is equal to 11. And we go, oh no, it's got this variable in it, how scary, right? Whereas if I had 4 plus 11 equals, you just add them, you'd say it's 15. That's not the answer to this. But you don't worry if you see numbers and then you have to find a result. But you do get scared when you see a variable sitting there, oh no, how do I find it? Well, we use those addition and multiplication properties that I just talked about, and we say, well, I have x plus 4 is equal to 11. I want to find x, so I want to get rid of this 4. Well, how can I do that? Well, if I subtract 4 from both sides, that's the additive inverse, right? If I subtract 4 from both sides, x plus 4 minus 4, plus 4 minus 4 is 0, so we have x, and 11 minus 4 is 7. X is equal to 7. We just changed it from being x plus 4 is equal to 11 to being x is equal to 11 minus 4. Oh, 11 minus 4 is 7. X is equal to 7. This isn't anywhere near as scary as you've thought it was. We start thinking about letters and we go, oh no, you don't have to be afraid of the letters. It's all stuff you've done before. All we want to do is get the letter by itself so we can do the same math we've always done. Let's try another example. What about 9 minus x is equal to negative 6? Well, this one could be considered a little more complicated, because with this, I've got this minus x here, so I could subtract x from both sides. I could add x from both sides to get it there. So that's what I'm going to do. So I'm going to say, let's add x to both sides. And you may not like this as much. It takes a little bit of work. This could actually be classified as a two-step, because I do this. So minus x plus x gives me 9. Equal to negative 6 plus x. Now I want to get x by itself. Well, if I add 6 to both sides, plus 6 plus 6, Minus 6 plus 6 is 0, so I have x is equal to 9 plus 6, or 15. Now let's take a quick look and go back at these and check. Sometimes you see things as solve and check. So we solved and found x is equal to 7. The check is going back in and plugging it in and making sure it works. So 7 plus 4 is equal to 11. 11 is equal to 11. Check. It's good. X is equal to 7. X equal to 15. 9 minus 15 is equal to negative 6. 9 minus 15, that's the same as 9 plus negative 15 is equal to negative 6. If you're adding opposite signs, you subtract and keep the value of the larger sign. 15 minus 9 is 6. And the sign of the 15 is negative, so negative 6 is equal to negative 6. Check. Okay, so it did work, so we can substitute in. Let's try a couple more single step examples. Five times x is equal to 40. Remember, when you have a number next to a variable, it just means multiply. So that's just 5 times x. So I want to get x by itself. Well, how do I get rid of this 5? If it's multiplying by 5, to get rid of it, I'm going to divide by 5. So I divide both sides by 5. 5 divided by 5 is 1, so we have x. 40 divided by 5 is 8. So x is equal to 8. If I want to check it, 5 times 8 is equal to 40. 5 times 8 is 40. So we have 40 equal to 40. Check. It's good. Now I am going to suggest, even if you recognize immediately what the answer is, practice the process. Remember, in mathematics and in many things, we start you out with something that's simple that you may be able to do already without using the process. But the idea is practice the process on something that's simple so that you can then apply it to things that are more complicated. So you may have seen, oh, 5 times 8 is 40, and you might have seen right away, oh, x is 8. But even so, go through the process and learn the method so that when you get something that's a little more complicated, 12.37x is equal to 51.62, I'm guessing you don't know off the top of your head what x is. I'm guessing that because I don't know off the top of my head what x is. But now if I know the process, I go, well, I need to divide both sides by 12.37. So x is equal to, and grab my calculator because I can't do that division in my head. So 51.62 divided by 12.37 gives me approximately 4.17. It's actually on my calculator 4.17299919159, and who knows where it goes from there. But it's the exact same process that we did here. Up here we may have recognized immediately, oh, it's 8. Down here we did not. So if we practice on the simple ones, then we get to the harder ones, we can actually do it. I sometimes do the reverse of that. I look at something that's harder, and then to make sure I've got my process correct, I take myself back to a simpler example and verify that it works how I'd expect it to be, and then I can apply it to my more complicated problem. One more single step. Let's go for x divided by 2 is equal to 48. Now again, even if you think you know this off the top of your head, do the work. And I say that because, one, it gives you the practice going through the process. Second reason I say that is because there's a tendency for us to look at things quickly and get the wrong answer. it's very easy for someone to go x over 2 is equal to 48, and they say, okay, x is equal to 24. Right? They look at it and say, oh, x is equal to 24. Whereas if we look at this, we go x divided by 2. Well, to get rid of that 2, we need to, since it's dividing, we need to multiply by 2. So we go 2 times x divided by 2 is equal to 2 times 48, right? Multiply both sides by 2. 2 divided by 2 is 1, so we have x is equal to not 24, but 96. 96 divided by 2 is 48. So see how easy it is to make a mistake if we just look at it quickly and say, oh, okay, I know what that is. So go through the process and get to the correct answer. So those are single step problems. And then we can also go to multi-step. Multi-step means that we have to do more than one process along the way to get that variable by itself, such as x over 4 plus 7 is equal to 21. So we still have this x, we want to get it by itself, but it's going to take us more than one step to get there. Now, when I solve a multi-step problem, I think of order of operations, but I run it backwards. Meaning, if I were to actually go through and do a calculation, the first thing I would do is divide, because division comes before addition. But if I'm trying to get x by itself, I'm actually going to do the opposite. I'm going to take what's further away and get rid of it and work my way in. Kind of like peeling layers off of an onion or peeling through something, slowly peeling your way into something. You've got x, that's what you're looking for. It is attached to this 4 by division, after which it is attached to that 7 by addition. So in my preference, what I like to do is just peel these things away. Well, the first thing I need to peel away is what's furthest away. This is on the other side of the equal sign, so we don't need to peel that away. When we peel these things away, we're trying to get them over there. So we don't have to deal at 21, it's already sitting on the other side. But now I go, oh, okay, well, this plus 7 is the closest thing. How do I get rid of a plus 7? I'm minus 7. So minus 7, minus 7, so now I have x over 4 is equal to 21 minus 7 is 14. Now I'm down to a single step. Oh, okay, so it's divided by 4, so I'm going to multiply by 4. I'm going to multiply by 4. 4 divided by 4 is 1, so x is equal to 4 times 14 is 56. So x is equal to 56. So that's using a multi-step process. Let's do another one. And realize that your variables don't always have to be x. Any letter could be used as a variable, even sometimes symbols and such, maybe a heart or something. And if you've taken IQ tests or any sort of like the brain teaser test and everything, they may do things like that and say, okay, if you've got 2 hearts plus 3 stars, and that's equal to this number, okay, then if you have 3 hearts and 1 star, that's equal to this number, and you're trying to figure your way through it. But it's the same thing, it's just variables. So let's say I have 8 is equal to 2m plus 5. So I want to solve for m. Well, I want to get m by itself. So remember, the m's there, the 2 is closest to it, the 5's further away, and we're trying to get everything onto the other side of the equal sign. So the first thing I'm going to do is subtract 5 from both sides. 8 minus 5 is 3. 2m plus 5 minus 5 is 2m. So now I need to get rid of this 2. It's multiplied, so I'm going to divide both sides by 2. 2 divided by 2 is 1, so I have equal to m. And 3 divided by 2 is either 3 halves or 1.5. So m is equal to 1.5. So doing multiple steps. Another example I want to show you is what if you have the variable in more than one spot? Okay, such as 11p minus 2 is equal to 4p. Well, now I have that p in multiple spots, so the best thing to do is get it together. We want to combine like terms. Now, this is where you have to be careful. There's a couple different ways we can do this. I'm going to go both ways to show you the pitfalls of either one of them. So first of all, I see 11p and I see 4p. I like to combine them in such a way that they stay positive. That's my preference. So in this case, I would say, well, to get them together, I'm going to subtract the 4p, because 11p minus 4p is still going to give me a positive number. So minus 4p minus 4p. So 11p minus 4p gives me 7p minus 2 is equal to 4p minus 4p is 0. Don't forget to put that 0 in there. So that's one pitfall. People do that and they lose the value there. Or even worse, they put a 1. Because they go, oh good, we canceled it out, it's 1. No, we canceled it out, it's 0. And now I can get in, continuing my multi-step process, okay, that's 7 times p minus 2, that's farthest away, so let's add 2 to both sides. So now I have 7p is equal to 2, and then I have this multiplied by 7, so divide 7 from both sides. Divide by 7, and p is equal to 2/7. Or you can turn that into a decimal, which turns out to be a 6-digit repeating decimal. So that's one way we can do it. So I combined the like terms first and had this 0 sitting over there that I had to remember to keep in there. Another option is I can go, well, rather than combining the like terms first, why don't I get this 2 over to the other side first? Well, actually, I'll combine the like terms again this time, but I'm going to combine them the other way so that they're already there and I don't have to move the 2 later. So I come in here and I'm going to get this out of the way, and I subtract 11p from both sides, minus 11p, minus 11p. Okay, 11p minus 11p, that's 0, so that's good. So we have negative 2 is equal to, and then I have 4p minus 11p, which gives me negative 7p. Now at this point I have to realize that I'm going to divide both sides by negative 7. Negative 7 divided by negative 7 is 1, so on that side I have p. Negative 2 divided by negative 7. Remember, when you divide two numbers with the same sign, the result is positive, and we get 2/7. So it works out to be the same. The concern is with this, you have to remember to keep this negative in here, because the real concern with this is people see, oh, it's combined by subtraction, so they want to add 11p. And if they do that, they'd actually end up with 22p over here and 15p over here, instead of no p's over here and negative 7p over here. So that's where you have to be careful with that. Just because they're combined by subtraction doesn't mean you add. You say, how is this combined with that? Well, this 11p is being added to that negative 2. And we talked about that when we were dealing with combining like terms and such. So a multi-step process. Well, what can we do beyond that? Well, we can go into dealing with completing a table. So what if we have an equation or a relationship between two variables, and we want to see what happens if one variable is a certain value, what's the other variable going to be? And vice versa, what if we have the other variable at some value, what is the other one going to be? So, let's try that. Let's say we have a relationship, the cost of producing X thingamajigs can be found using the following equation. So the cost C of producing X thingamajigs can be found by taking 517 plus 8x. C is the cost of production. And X is the number of thingamajigs. How do you spell thingamajigs? I'm not sure, so I'm just going to come up with that. Thingamajigs. Okay, so we have this relationship that the cost of production is equal to 517 plus 8 times X, the number of thingamajigs. In production, we would consider this the fixed cost. It's a constant 517. We would consider this the variable cost because the cost of this part depends on how many we produce. 517 is 517 no matter how many products we produce. That's a fixed cost. Whereas this value changes depending on the number that we're producing. So if we have this, let's complete the following table. So, number of thingamajigs and the cost of production. So, we're given the following. 17 thingamajigs. In another row we have 565. Right? In another row we have 32. In another row we have 1,173. And in another row we have 600. Okay? So now we want to find out, okay, if I produce 17 thingamajigs, what's my cost of production? If my cost of production is 565, and assume this is in dollars, but it could be in any unit, right? If the cost of production is $565, how many thingamajigs did we produce? If we produce 32 thingamajigs, what's our cost of production? If our cost of production is $1,173, how many thingamajigs did we produce? If we produce 60 thingamajigs, what's our cost of production? So now we can go through by just plugging in for the correct value. Now remember, number of thingamajigs is X, the cost of production is C, so the easiest thing for us to do at this point is plug in the X values, and we can find out what the cost of production is associated with that. So I have, for the first one, 517 plus 8 times 17. So I have 517 plus 8 times 17. Remember, order of operations says multiply and then add. So 8 times 17 gives us 136. So 517 plus 136. And then we add the 517. And we get $653 is what it costs to produce 17 thingamajigs. What if we produce 32? 517 times 8 times, plus 8 times 32. 8 times 32 is 256, so we have 517 plus 256. And when we add that, we get 773. And what about 600? 517 plus 8 times 600 is equal to 517 plus, that should be 4,800. So 4,800. So we add the 517 to that and we get 5,317. So we're able to fill in this side. Well, how do we fill in this other side? Well, there's two options. We can start plugging in numbers for C and then solving for X, or we can do the manipulation that we did previously to solve for X and then start plugging things in. So I want to get X by itself. Furthest away from it is this 517, which is added to it, so let's subtract 517. So I have C minus 517 is equal to 8 times X. We have a variable here, so we can't actually perform the subtraction, but we can write it. Now I've got 8 times X, so I want to divide both sides by 8. So I get C minus 517 divided by 8 is equal to X. So now I can plug in the cost, whatever it is, and find out how many thingamajigs were produced. So in this one I have 565, so for the cost, so 565 minus 517 divided by 8. 565 minus 517 gives us 48 divided by 8. 48 divided by 8 is 6. So we produced 6 thingamajigs to have a production cost of 565. Let's try this 1,173. So 1,173 minus 517 divided by 8. 1,173 minus 517 gives us 656. 656 divided by 8. So 656 divided by 8 is 82. So we produced 82 thingamajigs if we had a production cost of $1,173. So now the final thing I want to look at is just kind of a continuation of this. What if we have a formula? So instead of having just a relationship here, which is strictly, if this is the input, that's the output, many times we have formulas that have multiple variables in them. And it's a relationship of all of them. So remember for a triangle, that the area was equal to 1/2 the base times the height. So I have 3 variables here. And what we dealt with when we first talked about this was we said, okay, if I have the base and I have the height, then I can find the area. But now what we can do is we can say, well, what if I know that the area of the triangle, A, is equal to 58.5 square centimeters. So 58.5 centimeters squared. And I know that the base of this triangle is 13 centimeters. What is the height of the triangle? Right? So now we can't just plug in base and height to find area. We have the area. We have the base, we're missing the height. So what we can do is we can manipulate this using the addition property and the multiplication property so that we can solve it for h. So A is equal to 1/2 base times height. We want to get h by itself, so furthest away from that is the 1/2. So if I want to divide, it's multiplied, so if I want to divide to get rid of it, remember dividing a fraction is the same as multiplying by its reciprocal. So the reciprocal of 1/2 is 2, so I multiply both sides by 2 and I get 2a is equal to b times h, because 1/2 times 2 is 1. I want to get h by itself, which means I now need to divide both sides by b. So 2a divided by b is equal to h. And I now have h by itself. Well, I know what a is, I know what b is, so 2 times 58.5 divided by 13 is equal to what height? So 2 times 58.5 gives me 117 divided by 13, which gives me 9. So the height is equal to 9. 9 what? Well, we had, the area was in centimeters squared, the base was in centimeters, so the height must be 9 centimeters. So we can manipulate a formula to solve for the variable we're looking for and then plug in values and get an answer. And that's dealing with solving equations in a variable or solving algebraic equations and formulas.